Hi, and welcome to episode 8, or lesson 8 I should call it, of Maths with Kirin. Today we're looking at two skills. We're going to look at substitution first and then also rearranging formulae. The substitution skill we've probably actually used in some of the previous lessons, but it is a really good idea just to look at it explicitly because you may end up with a question in your assessment that is just simply substitution. So we're going to start with that today. Then I'll look and go through some examples with rearranging formulae, and then, as usual, we'll go through some exam questions so you can get a feel for how these questions are kind of asked in your assessment and how they're marked as well. So we'll get straight into it. Awesome. So substitution is replacing or substituting a given value for a variable in an expression. It's very convoluted. So pretty much we're just going to be given a value for a variable, and we're going to put that into the expression and work out what the expression would therefore be equal to. Now, sometimes you might have one variable that you are substituting for, sometimes you might have multiple, okay, but you'll be given the values of whatever variable you need to substitute for. You need to make sure that you remember your big math skills. So most common error in terms of following BEDMAS is that people, I just do a side note over here, if you have 4x squared, BEDMAS says that we need to do the exponent first. So if we know what x is, we square that value first, then multiply by 4. Quite often people sort of multiply the variable by 4 first and then square the result. Okay, that's not right, unless of course. So if you've just got 4x squared with no brackets, BEDMAS would say exponent first and then multiplication. So just be aware of that. And then the other thing to watch out for is negative numbers. A really good idea to use brackets to highlight when you've got negative numbers. And when we go through this first example, I'll show you just another sort of error that sometimes comes in. So for this first example, we want to find the value of this expression here. So it says 4b over c squared, when v is equal to negative 7 and c is equal to negative 2. So the first thing you want to do is just rewrite your expression with those values substituted in. So we've got 4 times negative 7 and then negative 2 squared. So here it is really important that you have your negative 2 in brackets because negative 2 squared is not the same as negative 2 squared with no brackets. This here is saying negative 2 times negative 2, which would give you positive 4. On the right hand side, we've got 2 squared, positive 4, and then we are subtracting that. So that would give us negative 4, and they're obviously not the same thing. So particularly if you have a negative number that you're raising to a power, make sure that you do brackets so that we've got our nice mathematical notation correct. And then from here we can multiply out. So 4 times negative 7 is negative 28, and negative 2 squared is positive 4. And then simplify our fraction. Coincidentally, this ends up being 4, and this ends up multiplying by 4, so they would end up cancelling out. Or if we simplify, we get negative 7 as the final solution. Okay. Second example question for substitution. So this case we have x as our variable that we can substitute for, so we know it's negative 3, and we're just going to substitute into this expression and find out the value of y would be. So y is equal to 3 times negative 3 squared plus 2 times negative 3 minus 1. So here we need to make sure that we square the negative 3 first. So negative 3 squared is positive 9. So that ends up being 3 times 9 plus 2 times negative 3 is negative 6 minus 1. 3 times 9 is 27. So we've got 27 plus minus 6 is actually just minus 6 minus 1. 27 minus 6 is 21 minus 1 gives us 20. Okay, so just substituting through. And simplifying as we go. So we're going to now look at rearranging formulae. So this comes up obviously in your assessment, that's why we're looking at it here today. You can have questions on this skill that might only be at achieved level, or you can have some that might be sort of all the way through to excellent level. It just depends on the complexity of the question. So I've got 4 examples to go through with you here, and then we'll get into looking at some of these ones that have come up in the exam so you can feel them. So for all of the 4 examples that I've got for rearranging formulae, we're trying to make n the subject. So when we're trying to make something the subject of an equation, it means that we want to get n is equal to something. The other way that they sometimes ask this question is they would say, write n in terms of t and w. Okay, so that means the same thing. We want to make n the subject of the equation. We want to get n equal to something. So to do that, we use the skills that we looked at when we were solving linear equations, because we want to isolate that variable that's going to be the subject of the equation. So everything else needs to move onto the other side of the equation, and we isolate the one that will be the subject. Okay, so those inverse operations is what we're using to do that. So if we go through the first example, to isolate our n, we want to move the t across first. So if it's multiplying n squared, we need to divide through by t in order to just get our n squared. So n squared is equal to 4w over t. And then the square, we don't want to have that. So n is equal to the square root of 4w over t. Now if we have something squared, we know that we normally have 2 solutions, the positive and the negative version. So sometimes you might see this plus minus out in front of the square root sign. That means that we're looking at the positive square root of 4w over t or the negative square root of 4w over t. Okay, now you'll see in the marking schedules as we go through the exam questions, often they will accept the answer if you have this, or if you don't, if you're just given a very generic equation like this. In some contextual equations, it might be that the negative, for example, might not make sense, and so you only need the positive solution, so just watch out for that. The second example here, we've got n on both sides of the equation, so we want to move those perhaps both to the left, and then move all of the other terms over to the right. So 4n stays where it is, 2n, we need to subtract it, so subtracting it from both sides means that it no longer appears on the right hand side. We've still got our 2a, and we want to move our 3a so that we're isolating the n's, so we add that to our right hand side, so that simplifies down to 2n to 5a. Dividing through by 2 gives us n is equal to 5a over 2. Can't simplify that any further, and so that's our final answer. Okay, the third example. This one is a little bit more challenging, and there's quite a bit going on, and there are a couple of different ways that you might approach this question. So I'll go through with how I would solve it, but some of you might approach it in a different way, and hopefully you'll still end up with the same or the equivalent expression at the end. So we want to make n the subject. So the first thing I'm going to do is move 7a to the other side of the equation. So this is 5 over k, so that stays the same. We add 7a, and that's equal to 3 over 4n squared. Okay, so from here, a couple of different options. You might move your 4n squared across and multiply. You need to multiply both of these terms, okay, by 4n squared. What I'm going to do before I do that is I'm going to write my left-hand side as a single fraction. Okay, and then I've got one fraction equals another fraction, and I find that a little bit more straightforward to solve. So if I'm going to write this as a fraction over k, I would need to multiply the numerator and the denominator of 7a by k. So we get 5 over k plus 7ak over k is equal to 3 over 4n squared. Okay, so these k's would typically cancel out, and you'd just be left with 7a. So this is equivalent to this, but the reason that I've done that is because then I can write this as one fraction like this. Okay, so adding our numerators together. From here, I'm going to take my 4n squared and multiply it by the numerator on the left, and I'm going to take the k and multiply it by the numerator on the right. And once I've done that, I've eliminated those fractions. So we get 4n squared times 5 plus 7ak is equal to k times 3, which we would normally write, okay? On this side, I'm going to leave the n squared out, but I am going to take the 4 inside the brackets. And the reason that I'm doing that, it might seem a little bit odd, I'm trying to isolate the n squared. So I want the n squared to be the only thing outside outside of the bracket and everything else to be inside the bracket, so that I can move this across to the other side and only be left with that n squared. So n squared stays out in front. 4 times 5 is 20, and then 4 times 7ak is 28ak, and that's still equal to 3k. So now we can have our n squared, and we're going to divide through by this 20 plus 28ak. We've got n squared, we're nearly there, we just need to get n. So in order to do that, we need to take the square root of both sides. So the square root of n squared gives us n, and we get the square root of 3k over 20 plus 28ak. Make sure that that fraction goes all the way across and that your square root sign encompasses that whole fraction. Again, we've got no context here, so we could technically have two solutions, a positive and negative version of this, because we had that together. Okay. So that's how I would approach that question. As I said, some of you might approach it in different ways. Hopefully you end up with this or an equivalent expression at the end. But I think that's, for me, the simplest way to go about that question. But that's quite complex, a little bit more difficult than the other two examples. Awesome. So the fourth example here, we still want n to be subject. So the first thing we're going to do is multiply through by 4x plus 3n. So x stays on the left-hand side, and we get 3 times 4x plus 3n. Expanding that out, we get 12x plus 9n. Moving our 12x to the left-hand side, so we can isolate the 9n. X minus 12x would give us negative 11x. Would be equal to 9n, and then dividing through by 9, so negative 11n over 9. Sorry, these should be x's. Sorry, so negative 11n is negative 11x is equal to 9n. It must be Monday. So negative 11x over 9 is equal to n. Now you can leave it like that. If you prefer, you can write it this way around. So n is equal to negative 11x over 9. This will be sufficient. Great. Sorry about the n's and x's. Not confusing at all. Perfect. So we'll look at some previous exam questions so you can see how these sort of come up and how they are marked. So this first question is a substitution question from the 2019 paper. It's asking us what is the value of 2x to the power of 4 minus 3x plus 5 and x is equal to negative 2. So we're just going to substitute negative 2 into x. So we get 2 times negative 2 to the power of 4 minus 3 times negative 2 plus 5. Remember, we raise our negative 2 to the power of 4 first, so 2 times 2 is 4, 8 times 2 is 16. So negative 2 times negative 2, negative 2 times negative 2 would give you positive 16. So we've got 2 times 16 minus 3 times negative 2, which is negative 6, plus 5. 2 times 16 is 32. Minus negative 6 means we're adding 6. Then we are adding 5, so 32 plus 6 plus 5 will give us 43 as the final solution. For this question, it's an achieved question only. You must get 43 in order to get the mark for this question. There is no alternative solution, and numerical errors in this question are not allowed. So sometimes in your paper, for example, if you're factorizing and you might have a numerical error, you may still get marked for that question. The substitution, they don't allow numerical errors because the whole point is substituting in a number and working that through. Okay, so just be aware of that. 43. Second exam question, again from last year's paper. So this is a rearranging question. So that we told that W is equal to PQ squared plus R, and we're asked to solve the equation for P in terms of Q, R, and W. So that just means we want to make P the subject of the equation. We want to get P equals. So P is on the right hand side. So in order to sort of get to that, we're going to move the R first. So to do that, we need to subtract. So W minus R is equal to PQ squared. Okay, and then to get P, we need to remove the Q squared. Now the Q squared is multiplying the P, so we're going to divide through. So W minus R divided by Q squared is equal to P. That's it. Again, this is an example of achieved question, an achieved level question. So we need to get the correct expression for P in order to get the marks for that question. Okay, no alternative solution for this one either. Next one is also from the 2019 paper, and it's another rearranging question, written in the same way. So we're given the expression and we're asked to write the equation or give the equation for K in terms of C, D, F, and G. So in other words, make K subject to the equation. So for this one, you'll see we've got an FK squared and we've got a 16GK squared. So the first step is to move those both onto the same side of the equation, and then the 9C squared and the 4D squared will be on the other side. So I'm going to move the 16GK squared to the left-hand side and move this 9C squared to the right-hand side. So FK squared stays the same. We're adding this, so we need to subtract it. So subtract 16GK squared. 4D squared stays the same. And then this is a negative 9C squared, so we add it to the side, which means we add it to the right-hand side. And we get positive 9C squared. From here, we've got two terms with K squared. So if we take that out in front, we can factorize. So F minus 16G in the brackets, and our right-hand side stays the same. So now this is our only K term. So in order to get that, we're going to divide through by F minus 16G. So K squared equal to 4D squared plus 9C squared all over F minus 16G. And then our last step is to undo the square. So take the square root of both sides. So K is equal to the square root of 4D squared plus 9C squared over F minus 16G. And again, we've got no context here, so we could technically, because we're undoing the square, have a positive and negative solution. Okay, so quite a lot more going on in this question. You can get all the way through excellence with this one. A lot more complex than the previous question that we looked at. So to get achieved, you have to have one valid step leading to both terms involving K squared being on one side of the equal sign, or one side of the equation. So you essentially need to get this first step here. Okay, K squared terms both on the same side of the equal sign, or you could have moved your FK squared onto the right side. That would have been fine too, so long as those K squared were both on the same side. For merit, you need to do that, and you either factorize your K squared terms, so you get to the second line, or perhaps something goes wrong when you're factorizing, but when you solve it, you get a consistent solution for whatever you had. Okay, but you still need to get this first right. Okay. And then for excellence, you get all the way through. You do not need the positive and negative sign. If you don't have that there, you still get full marks. You still get your excellence as long as you have the square root of 4D squared plus 9C squared over F minus G. And again, just take care to make sure your square root sign comes from the whole fraction and make sure there's no ambiguity there. Okay, so from the 2018 paper, so again, another example for rearranging. So give the equation for R in terms of A. So we want to rearrange this to make R the subject. So the first thing we might do is bring the 4 across. So if you have 9 over 4 times R squared, you can multiply through by 4. So if you're multiplying both sides of the equation by 4, because this R squared is multiplying 9 over 4, we can do that, and we would get 4A is equal to 9R squared, dividing through by 9, 4A over 9 is equal to R squared, and then Again, we're taking that square root of 4a over 9 is r. Okay, again, no context, so you can have positive and negative, but it won't impact your grade whether you have it or not. So this is an achieved level rearranging question. You may write it like this, or you may write 4 over 9 times a, all in the square root, is equal to r. That would be fine. Or you may notice that 4 over 9, you could actually take the square root of. So the square root of 4 is 2, and the square root of 9 is 3. So you could bring that out in front and then have your square root of a like that. Any of those are fine, plus or minus any of those. So, okay, so achieved any of those 3 options for you. And this is the last exam question that I have to go through today. So this is a substitution one. So the area of a garden is given by a equals 2, and then in brackets x plus 3x squared. And the question is asking us if x is equal to 5 and y is equal to 2, give the area of the garden. So we substitute x with 5 and y 2. And we brackets around that. 2 squared is 4, 5 times 4 is 20, and 3 times 20 is 60. Okay, so that 3 times 5 times 2 squared becomes 60. Bedmath rules say that we need to do the 2 squared first, and then we can multiply by the 3 and 5. And then brackets, so we've got 5 plus 60, so 2 times 65. 2 times 60 is 120, and then 2 times 5 is 10, so we get a. We have no units, but it doesn't tell us what these are measured in, so while we should have unit squared area, we don't know what the units are, so we can just leave it at 130. And this is another achieved question, and so just substituting through, getting our answer as a equals 130, the only solution. There are no alternatives for this one. So often substitution questions tend to be achieved level, and then the rearranging formula, as I said earlier, might be achieved, but also got all the way from excellent, depending on how many steps and how complex the question is. So that brings us to the end of today's lesson, lesson 8. On Wednesday, I'm back here at 5:30, and we're looking at solving simultaneous equations, but we're just going to focus on the substitution method for Wednesday. So I've got some examples for you, and then exam questions, how that works. And then on Thursday at 5:30, if you've got any questions, feel free to email me, and I can go through those on Thursday for you. So that's Thursday session. And then next week, I just throw my timetable up. So next week on Monday, we've got the second simultaneous equations lesson. So that's focusing on the elimination method. And then on Wednesday, sort of problem solving style questions and other sorts of things that we may not have covered in the other lessons. So 3 lessons to go. And then we're done. As usual, I hope you found it useful. If you did, please make sure that you share it with other people. Tell them about it, share the links, share the Facebook page, subscribe to the YouTube channel, all of those things. Awesome. And I hope to see some of you on Wednesday. Have a lovely evening.